Mastering steel, the heat treatment process. Welcome to our deep dive into steel's transformation journey. Heat treatment is a pivotal process that unlocks steel's potential, enhancing its properties to meet industrial needs. How do these processes make steel stronger, harder, and more ductile? Let's explore these fascinating methods together. First up is annealing, a process that softens steel, improving its ductility and workability. By heating the steel and then cooling it slowly, internal stresses are relieved. This makes it easier to cut, form, and shape, essential for precise engineering applications. Next, we delve into quenching, where steel is rapidly cooled, usually in water or oil. This hardens the steel, enhancing its strength and wear resistance. Hardened steel is ideal for cutting tools and machinery parts, where toughness is essential for performance under stress. Tempering follows hardening to achieve a balance between hardness and toughness. By reheating the quenched steel to a moderate temperature, we reduce brittleness while retaining strength. This process is crucial for creating durable tools that withstand impact without shattering. Throughout this video, visual demonstrations will showcase steel undergoing these transformative processes. Watch as steel glows under heat, is quickly quenched, and tempered to perfection. These visuals make complex concepts easier to grasp, enhancing your understanding of metallurgical processes. Unlocking the power of steel, heat treatment explained. Steel is versatile, used in everything from skyscrapers to scalpels. Carbon steel, stainless steel, and alloy steel each serve unique purposes. Knowing their properties is essential for choosing the right type for your project, enhancing both performance and durability. Heat treatment transforms steel's properties, boosting its strength and resilience. By carefully controlling temperature and time, engineers can tailor steel to specific needs. From hardening tool steel to toughening industrial components, heat treatment is a critical process. Precise temperature and timing are crucial in heat treatment. Too hot or too cold, too long or too short, and the steel's benefits may diminish. Mastering these variables allows engineers to unlock optimal steel performance and ensure reliability in demanding applications. In industrial settings, heat-treated steel withstands immense stress and wear. By refining its toughness and durability, components like gears and bearings achieve extended lifespans. Engineers maximize efficiency by choosing the right steel type and treatment process for each application. Heat treatment enhances the precision and longevity of tools, from cutting blades to drill bits. In structural applications like bridges and buildings, treated steel ensures safety and strength. This process is essential for achieving superior performance in engineering projects. Ready to revolutionize your use of steel? Dive into the specifics of heat treatment and explore how you can apply it in your projects. Subscribe for more insights and advance your engineering expertise by mastering these transformative techniques. Let's build the future with stronger, smarter steel. Join us in mastering the art of heat treatment. This knowledge is not just for curiosity but practice. Implement these techniques to refine your steel processing strategies. Subscribe for more industry insights and elevate your skills in metallurgy to new heights today.